As we learned in class, with projectile motion there are two types, horizontal launch and angled launch. So far we've learned everything about horizontal launch, but not everything is launched horizontally. So we're now going to learn how to approach an angled launch projectile motion problem. For starters, we're going to talk about what kind of the first things are that we need to do. When you approach a projectile motion problem, you list everything you know. That's kind of the first step. That's listing the givens. Along with listing the givens, you should check to make sure that all of your units match. If your units don't match, you should convert next. But if your units do match, you may move on to the second step with angled launch projectile motions, which will be to split your initial velocity into an x and y component. This is finding components just as we learned as we were working with vectors, and should hopefully be something that you are comfortable doing by now. After you do that step, you will then move on with the problem, figuring out what you need to know, what equations are best to find what you need to know. There are some other things that are unique to angled launch problems. Specifically, when you know that the y displacement is 0. In other words, your object begins and ends at the same height. So when this is the case, the time to the maximum height is equal to half of the total time. Again, the time to the maximum height is equal to half of the total time. In addition, the x displacement to the point where it reaches the maximum height is half of the total x displacement. One last important concept, this is true all the time, not just when delta y is 0, is the fact that at your maximum height, we'll call that h, the velocity in the y direction is 0. Does that mean the velocity total is 0? Absolutely not, because the x velocity never changes. So only the y velocity is 0. We're going to look at a couple of problems for this video that will go through these concepts in light of a problem. Specifically, we're going to look at example number 4, which is problem number 4 on page 152. A player is kicking a football. It tells us about the initial velocity of this football, and we want to know the hang time, the maximum height, and the ball's range. The very first thing that I do, even before I list what I know, with many of these projectile motion problems, is I'll draw a picture. The picture helps me list some things that are not clear that I actually know. So here is my initial velocity, which is 27 meters per second, and it's launched at an angle of 30 degrees. Okay. Next, I'll list what I know. I'll list things in the x direction as well as in the y direction. As has been mentioned previously in class, we always know that the acceleration in the y direction is negative 9.8 meters per second squared. This is not a horizontal launch, so we cannot write VIY equals 0. Instead, we will need to find VIY. We do know that the x acceleration is 0. And that's it. Or is it? Let's look at that picture. This ball begins on the ground. Where does it end? It ends on the ground as well. Because it begins and ends at the same height, delta y is equal to 0. Now that's everything we know. I've listed all of those givens. My next step is to find the x and y components of the initial velocity. Pause the video for a moment and find those components yourself to make sure that you're comfortable with finding components. You should have found those components to be 23.383 meters per second and 13.5 meters per second. Okay, so now that we have everything that we know listed, let's look at what we're looking for. In part A, we want to find the ball's hang time. That's how much time the ball is in the air from start to finish. Time is one of those funny categories, or funny quantities rather, that can be found in either direction. So let's look at what we know. Do we have enough information in the x direction to find time? Well, the only equation in the x direction is that velocity in the x direction is equal to displacement in the x direction divided by time. Because we don't have displacement in the x direction, we can't find time using that direction. So the y direction is going to be our go-to. Based on the information I know in the y direction, the piece of information I'm missing is v final. So I want to pick an equation that doesn't have v final in it. Delta y equals VIYT plus 1/2 AYT squared. Delta y is 0. That makes my life easier with this equation. I'll subtract one of these terms to the other side. I'll pick the 1/2 AYT squared. So minus 1/2 AYT squared equals VIYT. And then I notice that there's a t in every single term. That means I can divide both sides by t. On the right-hand side, those two t's cancel out. On the left-hand side, the t in the denominator gets rid of the square in the numerator. Then to isolate t, I'll divide both sides by negative 1/2 AY. And lastly, because I don't like having fractions in the denominator of something, I will get rid of that fraction in the denominator, which puts a negative 2 VIY in the numerator, divided by AY in the denominator. Now I can plug in numbers. Negative 2 times 13.5 meters per second divided by negative 9.8 meters per second squared. Plug all that into my calculator, and I find that the time for the ball in flight, the hang time, if you will, is 2.755 seconds. Now I'm going to stop and ask myself, is that reasonable? Is it reasonable for a ball kicked in the air to take 2.755 seconds to land? Absolutely. That's an absolutely reasonable answer. So I will box it. That's my answer for part A. Let's look at part B. Part B wants to know the ball's maximum height. How high does it go? Well, there's another given that we know at the maximum height. At the maximum height, we know that the velocity in the y direction is equal to 0. That's one of the facts we just learned. Now, because I am talking about the maximum height, I'm going to start at my initial point when the ball is kicked, and my final point is going to be at that height. So v final y is 0. Delta y is no longer 0 because I've changed my final point. Instead, delta y is what I'm looking for. Now, you can use 3 out of the 4 equations to solve for this delta y. It doesn't matter which one you use. I'll use the one that says delta y equals 1/2 VIY plus VFY times time. I don't have to do any algebra to solve for delta y in this equation. VIY is 13.5 meters per second, and VFY is 0. Now, you have to be careful before you plug time in there, because, as we just learned, the time that it takes to get to that maximum peak is half of the total time. So half of 2.755 is 1.3775. That's the time that it takes to get to that maximum peak. Multiply these out on your calculator, and you get a maximum height of 9.298 meters. Again, ask yourself, is that reasonable? Well, a classroom is almost 3 meters tall, so this is like 3 classrooms stacked on top of each other, or a 3-story building. While that's a pretty high height, that's not unreasonable. So we'll go ahead and box that answer. Finally, on part C, we're asked, what is the ball's range? Range is another word for how far does it go? What is the x displacement? As we learned earlier, there is only one x direction equation, and that is that the velocity in the x direction is the displacement in the x direction divided by time. So we're going to use that equation and solve for x displacement. To do that, I multiply both sides by time. Delta x is Vx times time. That's 23.383 meters per second times the total time of 2.755 seconds. This gives me an x displacement of 64.42 meters. Is that reasonable? 64.42 meters. Well, a meter is kind of close to a yard, and we're talking about kicking a football here. So have you seen a football be kicked about 65 yards? If you've watched football, especially professional football, you've definitely seen that before. That's a pretty common kick. So that is a reasonable answer. Now the next problem that we are going to do is very similar. This problem instead says that the player kicks the ball with the same speed, but at 60 degrees from the horizontal. It wants to know the same 3 quantities: the hang time, the range, and the maximum height. Your task right now is to do this problem. It's just like the previous one, but with some different numbers. I'd like you to complete this problem and show it to me in class tomorrow, so that I know that you've watched this video and understand this problem.